We're going to go ahead and do example 5, which is showing that n factorial is greater than 2 to the n for n values greater than or equal to 4. So here's one of those rare situations where you're not showing p sub 1, right? Because they specifically tell you, yo, this isn't going to work until you hit n is 4. So you're not going to prove p sub 1, you're going to prove p sub 4 as your first term. So we go ahead and do our proof, right? My first step is going to be to show that p sub 4 is true, right? So show p sub 4 is true, right? So that's going to say 4 factorial is greater than 2 to the 4th. Well, that's a 24 is greater than 16, and it's absolutely true. Great. Okay, second step is I'm going to have to assume p sub k, right? So I'm going to assume that k factorial is greater than 2 to the k, and that is a fact that I'm going to be able to use for my manipulations in a minute, right? And then now we're going to get to my third step, which is the hard one, right? So what I want to show, my big proof, is to show p sub k plus 1, which is saying I'm trying to show that k plus 1 factorial is greater than 2 to the k plus 1. Now, remember that when we do this, like if we think about our end game here, the end game is probably going to be to have some sort of a chain that looks like this, right? So when I look at this, my end game is probably going to be to have this end, the k plus 1 factorial, is greater than some missing link that I don't know about is greater than a 2 to the k plus 1. And how I get to that missing link is going to involve this fact somehow, right? So there are two ways to get to that fact, okay? One way to get to that fact is to, so there's two options, right? One way to get to that fact is to try and make the left-hand side, the k factorial, look like a k plus 1 factorial, which is fine. I'd be multiplying by k plus 1 on both sides. The other way to do it is to try and multiply both sides by a 2, which would make this side look like the 2 to the k plus 1. So I'm trying to make one of the two sides of my fact look like one of the two sides of my final statement. Again, there are two logical ways to do it. I could either multiply this entire thing by 2, which is fine, or I could multiply this entire thing by k plus 1. Either of them should result the same way, right? So let's walk through how that works a little bit. Okay, so I'm going to go ahead and pick that I multiply both sides by 2. So what I'm going to do is I'm going to try and make this side look like this end of the expression, okay? So I'm going to take that fact, right? I'm going to take that fact, and I'm going to times it by 2, okay? So I'm going to get 2 times a k factorial. That's not a 2k factorial. It's different. It's a 2 times the quantity k factorial, right? Is greater than 2 to the k times a 2 to the first, which would be the same as saying 2 times k factorial is bigger than a 2 to the k plus 1. So what I've done now is I've made one chain of this link look like the bottom chain of this link, right? So now the big question mark is this seems to be my missing link, right? So the 2 times the k factorial, this seems to be my missing link, right? If I can show that 2 times k factorial is smaller than k plus 1 factorial, then I can prove that this statement is true. So if I can show that this missing link, that 2 times k factorial is smaller than a k plus 1 factorial, I can show, in fact, that this thing is true. So let's walk through how we can show that. So again, where I'm at right now is that I now know I have k plus 1 factorial. I'm trying to show that that is bigger than this missing link, which is bigger than a 2 to the k plus 1. Well, what I have figured out in red using my fact is that 2 times k factorial is bigger, and I don't need those parentheses because factorials fall where exponents fall, so the factorial takes precedence over the 2, but I'm putting the parentheses just so you don't get it confused. 2 times 2 rather to the k plus 1. I know that this is true, right? This is definitely true. So if I can show that this space is true, that k plus 1 factorial is bigger than 2 times k factorial, then I can show I'm correct. So let's think about what a k plus 1 factorial is. K plus 1 factorial is k plus 1 times a k factorial, right? And I'm trying to show that that's bigger than a 2 times a k factorial. Well, if you notice, they both have a k factorial. So essentially, I could divide by k factorial, which is non-zero, and say that for any k plus 1 greater than 2, this statement has to be true, so k is greater than 1. Well, I already know k is greater than 1 because they told me to start at 4. So now, if I want to finish out my proof, I know that for k values greater than 1, right, for k values greater than 1, k plus 1 factorial is bigger than a 2 times the k factorial, which is bigger than a 2 to the k plus 1. So I can cut out the middleman and say that I have proven that k plus 1 factorial is bigger than 2 to the k plus 1. Check. So Again, whenever you're proving these missing links, you're usually going to have to find some caveat that says, oh, the missing link is only true for some certain k values, but those k values are always going to fall as a subset of the original n values that were given, so that's how your proof works. Again, you make that missing link. You could have done the proof the other way. Instead of multiplying the whole thing by 2 like I did, you could have multiplied both sides by k plus 1, and it would have come out the same way, but that's the gist.